So what I'm trying to say here is you'll have one single SAP system which has two components. One is MDG component, other one is ECC or S4 component. Okay, so this is my ECC/S4 component. Okay, now this particular whatever I'm showing you here, this we call it as an active area, that database tables that you have for the to store your master data. Okay, that is your material master tables or customer master tables or vendor master tables. Okay, so by default you'll have this one. Now coming back to MDG, we need to corresponding to this particular database tables, we need to create our own tables, staging tables, where the data, because initially the data should be get created into this MDG staging tables, and on the staging record we will be doing all that applying all the governance principles, validations, everything. And once the record once the record gets approved, that is the time where the record will be pushed from my staging area to or my staging tables. This we call it as a we call it as a staging area, or else we can also call the records that get stored into this particular table, we call it as a inactive records. So these are active records. Okay, so now after all that validations, the derivations, review process, everything, finally the record will be moved from my staging or inactive area to the active area. Okay, so now that means this particular staging area that I'm talking over here, this particular staging area is already available for the out-of-box objects. Okay, so for the custom objects or any master data which is not covered as part of the out-of-box, then that we call it as a custom object. So we need to build this kind of staging area for that one. Okay, so that the two scenarios that I'm talking is one scenario where we will create this particular staging area. Okay, so to bring any object into the governance scope, okay, the custom master data into governance scope, then the first step that we need to do is we need to define the data model for that particular object. Okay, so that means we need to create the staging tables and all those things. Once this is done, the second step is we need to develop some UI applications for this particular object, because user has to log in and he has to enter the data, right? So that's where actually we need to provide some UI applications. We need to develop the UI applications. Okay, once these two are done, then the third one is, that is the third step. So this is place where we will be defining the governance. We will be defining the governance processes for this particular master data object. Okay, so that we will be discussing under process model topic. Okay, so then for the same object we need to define the data replication also. Okay, so then that is what actually you'll be doing all these things from scratch for a custom object. So this is our first scenario. Okay, so after that the next scenario will be for material master, business partner, customer objects, those staging area, those data models already developed. That's where we call it as out of box. You need to just configure it and just use it. Okay, the only changes that you can do for the standard objects is you will be adding your custom content, like your custom attributes. You will be enhancing the data model with the custom attributes. You will be enhancing the UI application with the custom attributes, and you'll be defining the workflows, process modeling, and everything for the standard objects. Okay, so we will start with the custom object. So the main intention that I'm going with the custom object is in the custom, while creating the custom object, so then we will be right from the scratch, we will be creating these two processes, data model and UI applications, where we will be developing from scratch. Okay, after that, from process model onwards, it will be common, like whether I define a governance process for my custom object or I define a governance process for the standard object, it remains same. Okay, so first let's to get into more details and understand, let's create our own data model and UI application. Then once this is done, once the process modeling, everything is done, then we also see the same thing. We'll apply for the standard object, how to enhance the standard objects as well. Okay, so is this clear to everyone?
Yes, Akshay.
Great. So now
it's clear.
now let's start with the data model. What is there in the data model? So if you look at the standard objects like material master, I'm just taking the example of material master. So in case of material master, on ECC side or on S4 side, we'll have some bunch of tables. So those tables are MARA, the table names I'm giving, MARC for to store the plant information. Then you'll have MVKE to store the sales related information, MBEW. This is to store the valuation related. Then you will have also MAKT to store the descriptions, language, the material descriptions in multiple languages. Likewise, you have so on and so forth. There are a couple of bunch of tables are already there. Okay. Now every table, you also have something called, the table will contain some attributes. Okay. Now this is on ECC side. Okay. Now when it comes to MDG side, okay, at the top level, you will have something called data model. It's a logical name. You can give anything, data model. Okay. So for material master, the data model name is MM, name of the data model. Under data model, you will have something called entities. Entity. I'm just giving entity 1. This is another entity, entity 2. And this is another entity, entity 3. And entity 4.
Actually, just a quick question. With the ECC S4 side, those attributes are the same thing as fields, right? Same thing. When you say attributes, it's on the ECC S4, it's called fields also, right?
Yeah. It's a table and the table fields. That's it.
Table and table fields. Okay.
Yes. Okay. Now on MDG side, we have at the top level data model, and data model is nothing. It's a collection of entities. Okay. Now each entity contains certain configurations at entity level. Okay. Now we can assume that this entity is equivalent to your table on ECC side. Okay. The entity name. Okay. So the entity that you are creating under a data model, that we can assume it as a kind of a table corresponding to your active area table on ECC side. Now at the table level, we will set some configurations. Okay. In the same way at entity level also, we will set some technical attributes or some configuration we will do at the entity level. After that, once that is done, every entity contains certain fields. We call it as the attributes here. Attribute 1, attribute 2, attribute 2, and attribute 3. Okay, so you'll have some attributes under entity. So these attributes are nothing but the attributes that you will have at your MARA level. Okay, so now if you look at this one, at the top you have data model. Data model is nothing but collection of entities, and entity is nothing but collection of attributes. So this is the hierarchy. Now, when you have more than one entity in a data model, you need to define the relationship between those entities, because these entities are have interdependent. Let's say, for example, if you take example of on ECC side also, so there is a relation between these tables. What is that relation? Whenever you are extending a plant extending a material to a plant, that material first should exist in MARA table. For that particular material only, you will be extending it to new plants. So this is your base table. MARA is a base table, and you will have a relation between that parent-child relation kind of thing between MARA and MASI. That's where you will have a foreign table lookup, foreign key check also will be there. So the material number in the plant should exist in MARA table. Okay, so then only I can extend that material to plant. So that means there is a kind of relation between these two tables. Similarly, between MARA and MVKE also, there is a relation. Similarly with the valuation. Okay, so likewise, here, because we are representing these tables on ECCs on MDG side as entities, so whenever you have more than one entity under a particular data model, you need to define the relation between those entities. So once you create data model, entity and attributes and define the relationship between these entities, that is your data model design is completed. Then what we will do is, there is something called activation button. So once you click on activate button, that is the time in the backend MDG framework will read this information and it will create a staging tables for you. So in MDG world, we don't create directly the staging tables. That means you don't go to SC11 and create the table. We always do the create the staging tables by using this data model configuration. You create the data model, you create the entities and add the attributes, define the relationships and click on activate button. The corresponding staging tables for every entity, it will generate the staging tables in the back end. Okay, so that is what we will see today. Okay, now let's go to one data model. The transaction code is MDG. IMG is the transaction code where we can actually do all that MDG specific configurations. Okay, under MDG IMG, if we expand the general settings, there is something called configuration node here for data model. Okay, so the first one is edit data model. Okay, let's look at the standard data models, how it look like, just to visualize this. Okay, so as I said, at the top you will have, these are the out-of-box data models, then you have BP, and you'll also have this is for the finance. Okay, so finance, for finance OG data model will be there. In this particular system, it's not yet activated. When we actually today, usually the training system that we use, that is not yet, it looks like it is down. So I'm using some other system. But when we, once the system is up, and when we switch back to that training system, so then I will show you that other data models also for article master, EAM, even for the finance one. Okay, for now, these are the two standard data models that you can see, material and business partner. Okay, so this is the data model. Once you go to this entity types, data model is collection of entity types. So now you can see all these are the different entity types. Under material master, there are 156 entity types are there. Okay, so out of all these entity types, the parent entity type, that is nothing but corresponding to your Mara table, here on MDG side, there is one main entity type is there. So that entity type is nothing but the name of that entity type is material. Material is the entity type, name of that particular entity. So this particular material entity is equivalent, or it is equivalent to your Mara table on ECC side or S4 side. Okay, so let's first open that.
Okay. Actually, quick question.
Yeah.
So with this particular data model, this comes out of the box right? So
yes, that's true.
We can't make any changes within this, correct? Because it's comes standard, so we can't make changes. Is that right?
We can do the changes, but there is a point here. The thing is that we are not supposed to touch the standard entity types and the attributes that are already there on the standard. What we can do inside this particular data model is, I can create my own entity type over here under
Okay.
Okay, or else I can add some attributes. Now this is my material entity type. If I go further down, you can see here I'm at data model. I'm at a material entity. Under that, I have certain attributes over here. So these attributes are equivalent to my table fields under Mara table. Okay. Now, if I go to edit, what we are not supposed to do is, don't never ever touch anything in the standard. Okay, the standard attributes or anything. Though it shows that it's an editable one, but we are not supposed to touch. Okay, so what we can do is, you can scroll down. Okay, you can click on new entry. If at all I wanted to add a new attribute, you can just click on new entry. Okay, now it will be enabled for you to add your own attributes.
Okay, so you can add your own attributes.
Yes, yes, yes. So either you can add attributes under the existing standard entity type, or else you can create your own new custom table, custom entity as well. You can add a custom entity. How I can do? You can go back. So okay, here you can actually click on new entry. So when I click on new entry, it will ask me to create my own entity type over here. I can create a new entity type altogether, and under this entity type, I can add attributes as well.
Can you also copy the data model and change it and create something like that? Can you copy that?
Yeah, I mean, technically that is possible, but usually we don't do that one.
It's not business. Okay.
Because what happens is in the backend, in the backend for this particular data model, there are certain technical the objects, classes, programs. There are some SMT mappings, UI applications, everything are there. So when you copy this into a custom data model, then what happens is it won't work properly. Either two cases, either you create from scratch your own data model, or else you extend the standard data model. These are the only two cases that we usually do in MDG.
Can you go back once more and show me once more how you went to custom data model? If you don't mind.
Sorry, yeah, okay. Yeah.
Because there's two ways, right? One, you can add attributes to the actual MM model, and then you can create your own custom model and set the attributes, set the entity type, everything. Correct?
That's true.
Okay. Okay. Because the last step, can you just go over it once more?
What is that last step means?
Where you added.
Okay.
You added attributes, and then after that, you did one last thing. You did another thing.
Okay, got
for
it.
MM.
Yeah. So,
sorry.
We can create a new entity under MM data model. Okay, so let me go back.
Sorry, actually, I'm making you do this again.
No problem. So this is the first step where we need to create an entity, custom entity. Once you create the custom entity, that's where you need to set all these the properties for your custom entity, and then after that we'll go back and add the attributes under this particular entity.
Okay, yeah, this is what I wanted to see. So you click new entries and then you came here. Okay.
Yes.
So entity type is the table, or is it
entity
still
type,
a logical?
it's a logical name. Yeah, that's true. So it's a logical name. Okay, but once I do all my changes, right, I create my entity or I add the data model, add attributes and everything. I will select this, my data model, and I click on activate button. This is the time your MDG framework will look at your current data model changes, and it automatically adjusts the staging tables, or it will create a new staging tables, depends on the action that you have done. So your data model, entity type, attributes are logical definitions here. Okay. And the activation part is the time where actually the staging tables get created.
And then eventually you would assign it to a physical table, right? Like Mara or Marcy.
Yeah.
At some point, these attributes.
Yeah. So that we will do it towards end. So I'll explain there how to link that one. There is something called SMT mapping will be there, service mapping tool. So that's where we will be discussing how we can actually map this to the standard tables.
Okay, cool.
Thanks, Akshay.
Yeah.
Thank you.
So now let's start with our custom data model. Okay. So just a minute. If the system is available, we can directly create the data model there. So I think the system that got crashed, it seems. So let's use for today this system, and from tomorrow onwards we'll get the actual system. Okay, but anyway, I don't create anything. We will just cover that the theory part, and once the system is available, we'll try to create the entity type, the data model and everything in tomorrow's session. Okay, so now let's we discussed till now is data model. Okay, so this is data model, and if you go to the entity types, okay, so these are the different entity types that we have. Okay, out of this, let's take the main one for business, for material master, that is nothing but material entity type. So these are the name of that particular entity type. Okay, so this is the material entity. Now, if at all I wanted to create a new entity under this data model, okay, then before this data model, let's go back to entity type. Let's go back to the data model level settings. Okay, so if at all I have to create my new custom data model. Okay, so for the custom data model, always the naming convention that we need to follow here is, okay, so the naming convention that we need to follow for the standard data models, the names are something like this. is the data model name, BP is the data model name, OG is the data model for finance, AR is the data model for article master, U1 is the data model for EAM objects, plant maintenance like BOM, functional location, equipment. So all will be covered under this particular one. Okay, so now these are the standard data models out of box. Now, when it comes to the custom data models, if at all I have to represent my employee master or anything, my plant as a data model I wanted to represent, always any custom data model, it should start with Y or Z, followed by, it's a two character one, alphanumeric, followed by, you can have any other one like Y1, or else you can have YA, something like that, YX, like Z1, Z2, okay, or else ZA, ZB, something like this. Okay, any custom data model, it has to start with Y, and it should be two character one, alphanumeric. Okay, so this is a naming convention we follow usually for the data models. Okay, so once you create the data model, let's say for example here, let's go to edit, okay, click on new. I wanted to create a brand new data model. So the name, it will follow something like this, Y1. I'm just giving Y1. Okay, and I'll set the description. Let's say for example, it represents your data master object. Okay, so since material master is already there, so we don't copy that material master, but we will create something, a smaller data model by taking that material master example only. So the example here, the data model that we are thinking is like, you'll have a material, and that material should be we call it as a product or something, and that product should be extended to multiple plants. So this is the simplest data model. So that means I should be able to create a product, and that product should be extended to multiple plants. So this is a simple data model that we are thinking. Okay, so I'll say product master as the description. Okay, now after that, you have something called active area. When you're creating the data model, you need to input this value, active area. So what is this active area? So what happens is, if you remember, we discussed about reuse mode versus reuse mode versus flex mode. Okay, so let me give a quick recap. This is my MDG system. This is a ECC or S4 layer, and this is my MDG component. Okay, so now this is the staging area, this is the active area. Now, so in case of reuse mode, what happens is, once initially the user log into MDG system and he enter the data, that gets stored into the staging table, and after that all the approval process, finally the record will be moved to my underlying the ECC tables. Okay, so that means whenever this process, we call it as a activation process. Activation process in MDG terminology. Activating the record means the inactive record will turn to active record, and that record should be available, made available in the active area. Okay, so this process we call it as an activation process. So at the time of activation process, now in case of reuse mode, what happens? The record will be deleted from my staging table and it will be moved to the underlying the actual master data tables. This is the reuse mode. So the record will get deleted here and it will get created over here. Okay, now in case of flex data model, what happens is your active record, the inactive record will be there in the staging area, and once the activation process triggers, then automatically the active record also gets stored into my staging table only. That means your inactive record from the staging table will turn to active record in the staging table. It won't automatically move to your underlying ECC tables. So this is the flex concept. We discussed this one. Okay. Now, whenever you are creating a data model, it has to be either reuse mode or it has to be either flex mode. You need to tell to the system that whether you are using the reuse or flex mode. Now, this is the one which tells that whether it is a reuse mode or flex mode. Okay, either if I keep it blank or else if I select something called MDG, either I can keep it blank or I can select it as a MDG. In both these cases, it indicates that it's a flex mode. Okay, so there is no either if you have MDG or even if you keep it blank also, then by default this data model is considered it as a flex mode only. Okay, so now if at all you wanted to go with the reuse mode. Okay, so reuse mode means if you look at the standard material master, it is not hiding.
Yeah, Akshay, a quick question.
Yeah.
Sorry, I wasn't there for that class, but have you already covered the pros and cons for reuse and flex mode?
It's not about the pros and cons. It about depends on the your requirement, but it covered in the previous session. We covered in detail that active area versus reuse mode versus flex mode.
Okay, and this both modes can be applied on the hub approach, or it's only for the
can you come again? Your question?
so
Both
the reuse and flex mode, it's also applicable to the hub model, right?
Yes. So you can hub versus co-deployment is a one concept in which system you consider it as your master data system, and once you decide that one, the next one will be like your reuse versus flex mode thing. Both are two different things. In hub, I can have reuse or a flex also, because you can see material master and business partners are designed by using the reuse mode, whereas finance is designed using the flex mode. So that means in a MDG system, you have these three objects, whether it is a hub or co-deployment. Irrespective of hub co-deployment, you can have both these approaches. Okay, so now as I said, for finance objects, you will find that active area can be blank or MDG. Other than that one, if at all you see anything else, something like you can see here, material is there, partner is there. Okay, so other than that blank or anything else, then that means this consider it as an active area. Now how this came, this active area, this description, material or partner, that I will show you that. Okay, so okay, now this is nothing but this material master is defined it as a reuse mode. Okay, now how I'm saying it's a reuse mode, you can see here there is something called active area is assigned to this one. Other than MDG, there is some active area is assigned to this one. Okay, so what this active area, we have to create this active area. Okay, so that means this is a logical representation which represents your active area. Okay, so that means if you select this particular one, there is something called reuse active areas. You can see on the left hand side. Okay, so once if you go further here, okay, so this is what you are seeing over there. So this particular active area is a logical representation. It's a free text. When for your custom data model also, you can create your own active area. You can create your own active area with your own free text over here. What is important here is on the right hand side, something we are assigning some class. Okay, this is very, very important, this class. Okay, so SAP, what is this class? We call this class as a something called access class. Access class, we call it as this one. Okay, so what this access class will do is, let's say for example, this is your MDG system. No, it is not auto hiding. Okay, so this is your MDG system. You have your ECC or S4 component. Okay, MDG component. Okay, now this is the staging table and this is the active area. Okay, so this staging table represents your data model. Okay, it represents one data model, one master data. Okay, now what happens is there is something called in MDG, you have something called access class here. Access class. Okay, so this access class, what happens is, now as I said, once the final approver approves that record, okay, so then I said the activation process will get initiated. What this activation process will do, it will actually remove the record, it will read the record from your staging table, and it will push that record to the active area, and the record from the staging table will get deleted, and it will insert a new record. Okay, how it will happen? This is the one, this access class is the one. So what happens is, this access class always acts as a bridge between your MDG layer versus your ECC layer. So now the final approver approved the record. So then what happens, once the final approver approves that record, this access class will read the record from your staging table, and it will actually populate all the required, it will take the data from your staging table, your material data, plant related information, valuation, sales, all the views of material master data, it will read from the staging tables, and then it will push that, it will create basically the record in your active area.
Hello, Akshay.
Yeah.
But in case of flex mode, it will be blank, right? There will be no access class.
Exactly. We'll come back to that flex mode little later.
Okay,
First, let's try to understand further in case how it works in the reuse mode. Okay. So
Okay.
only this access class is applicable for your reuse modes only. Okay. So now this access class will take the responsibility of reading the data from your staging table and pushing down to your actual master data. Okay, so this is an automatic process. In case of reuse mode, once the final approve clicks that approve button, in the backend, in the workflow level, we will assign something called activation step. Once you assign that activation step, this particular class will get come into picture, and it will push the data. And SAP has provided this access class exclusively for material master. One access class for material master. Okay, now similar to this one, there is again another access class available for business partner. Similar to this, there is another access class available for article master, and there is again another access class available for all EAM objects. Okay, so that means for every custom data model that you are going to create, okay, for that one, if you decide to create it as an using reuse mode technique, then it is the person's or the team's responsibility to create this access class. We need to create. You cannot use the access class that is created for material master for other objects. Okay, so that's why I said when you are copying this data model to some other one, so this data model is tightly integrated with your this access class and everything. Okay, so when you copy your data model into some other one, so then I think it will create some issues. It won't work as expected. Okay, is that's it. We cannot copy, we cannot do anything. Either you can just simply enhance and use it. That's it. Okay, now this access class, this is first one. Okay, the save part, what we are calling is here, the save part will be taken care by this access class. Okay, now there are n number of things this access class will do. As I said, it acts as a bridge between your MDG layer and ECC layer. So there are n number of things it will take care. One example is save part. Second example is read part. Okay, so what happens in case of read scenario? Okay, let me show you quickly. In case of read scenario, I'm logging into MDG UI.
Sorry, Akshay, what is the save part? What do you mean? Can you explain a little bit?
Okay, so the save part is nothing but, okay, so this is the one which I'm talking. The save part means actually it's a, basically we can call it as a save or create part, material creation part. Either it can be create or update or anything. What are the changes that you do on the master data in MDG? Finally, what is your ultimate goal? You wanted to reflect the changes back to your ECC, specific to the master data. So that will be that part will be taken care by this particular save thing. It can be the creation of a new material, updation of a material. Okay. So now the other thing is, let's say, for example, I log into the material master home page. Just take my time. So I'll go to NWBC. It takes a couple of minutes. Okay, that's fine. So the other part is the read scenario. What happens? I created a material, activated the material final check. I mean, the approver approved that request, so that the record got created in my underlying ECC tables, and that record got deleted from my MDG. Now another user wants to do some changes to the same material. Then what happens? He will go to MDG UI application. He will search for that particular material. So once he search for that particular material, so what happens is, and he wanted to edit that. He wanted to edit that material. So during the edit time, what happens is, again, this particular access class will read this particular access class will read the data, and it will load that the record into your staging area. That will be done by, again, your access class only. This access class will do that activity. Okay, so now it will read the data, complete material master data from your all tables from the underlying ECC active area, and it will load that record into your staging tables. Now on the staging record, I will do all the edits, and finally once I approve that request, then again that the delta changes will be again updated back to my ECC. So that is a read part. Okay, again that will be done by your access class only. So that's why I said it acts as a bridge between your MDG layer and ECC layer. The other thing, the other part, okay. So in this, while doing this particular save or anything, right? So what happens usually on ECC side, you have SPRO configurations for your material master. If it is a material creation scenario, so then what happens when you are creating a material, you will log based on the material type. Material type drives a lot of things for the material master. Okay, so all that what number ranges it has to use, what material views it has to enable. So all this depends on your material type configuration. So where you do that configuration in SPRO configuration. Okay, so this SPRO configuration is your part of this particular ECC layer. Okay, so now if I'm creating a material using my MDG layer, then what happens is, this particular access class, as soon as on the UI you select a material type, okay, so this access class will, every time where any action that you do on your UI, so this access class always look into your the SPRO configuration specific to that particular material master. And if there are any errors are there, if you are not entering the valid, if it is a defined it as an external material number, and you are not entered the external material number, then it will throw an error message on your MDG UI. How that happens? Every action that you do on UI application, your access class will always look back into your SPRO configuration through this access class. It will validate the data that entered by the user on the UI, and if there are any issues are there, that errors will be shown on your UI application. Because we are not doing any in MDG layer, I'm not doing any SPRO configuration. I don't have any SPRO configuration. The SPRO configuration is already available in my underlying GCC. So that's where MDG will reuse the configuration, SPRO configuration, and it will react based on the data that user entered on the UI application. So that is also one of the another important point. Okay, so why it is taking this much of time? Just give me a minute. Reopen. Okay, so that is also again another part of your access class. Okay, so that is reading the data. Other thing is when I say SPRO configuration, so whether what fields has to be enabled based on the material type, we will configure some attributes should be mandatory, some attributes should be optional, some attributes should be hidden, some attributes should be read only. So all those configuration will be doing under SPRO. So that will be actually, if that means what I'm trying to say here is, if you are trying to create a material using MM01 in this particular layer, okay, how the system behaves, the same way, even if you are trying to create a material using MDG UI application, it behaves in the same way. Okay, only there in ECC side it will be SAP standard transaction. On MDG side it will be the browser based NWBC WebDynPro based UI applications. But the behavior, the data that you are entering and system reaction, everything remains same. Okay, so how this happens? Okay, because of this particular access class. This access class has got a lot of methods, and it will trigger those methods based on the actions, and those methods will look into your SPRO configurations, and it will actually show you the behavior. It will react basically on your UI accordingly. Okay, now there is something called authorizations also, authorization checks. So what happens usually, if at all in MDG, in material master, if you go to MM01 and you wanted to create a full-blown material, you should have authorization objects for to create the basic data, authorization object to extend the materials to a plants. You should have an authorization objects to extend that materials to different sales arcs. Okay, so this access class that is on your MM01 side, ECC side story. So the authorization objects are M star, mat star, M star, something like let me just quickly. There are some standard authorizations are there for everything, for sales view, plant view. That is something M underscore, mat underscore, MVKE, and M underscore, mat underscore, MARC. So something like this. So these are the different authorization objects are there. That is, without MDG also, you need to have these authorizations for your user ID if at all you wanted to create a material using MM01 transaction. If one of the authorization is missing, that respective view you cannot create. Now in MDG also, if at all you are creating materials using MDG application also, it will relook into the same authorization objects. You no need to again have a separate authorization objects at MDG level. Your MDG framework reuses, it checks that whether you have the right authorizations or not. It will look for these authorization objects only. So that authorization checks also will be performed. Okay, and this access class also will perform some of the standard validations. Okay, so it will perform certain standard validations, in the sense the same validations that I just explained, like depends on the material type, some of the default values, if at all you have configured, this is a default base unit of measure, or probably if this is a mandatory value that you have not entered. Okay, so those validations will be done by again the same access class. Similarly, you will have something called derivations also. Okay, so these derivations also will be performed by this access class. And after all this thing, once the material got created successfully or the material got updated successfully, this access class also triggers your data replication, because you have to it initiates the replication process. And if you configure any target systems, that replication will take place and the data will be replicated to the respective target systems. Okay, so now this is the responsibility of access class to do all these activities in the back end. Okay, now if you look at this particular material master, okay, MDG IMG, general settings, data model, edit data model. Okay, so this is my material master and the active area is defined. So it's a logical representation. Basically, this one links to the technical name of your the access class. Okay, select your data model, go back to this active area. Okay, so this is the access class. Okay, so this is the access class and this is the name of your access class. Okay, so technically, if at all someone wants to look at this, how it look like, I'll just quickly show you. This is for the technical people. Okay, so if you go to SE24 and look at this particular class, it has lot of methods. Okay, you can look at this one. Authorizations, for authorization checks, these two methods will come into picture. Okay, so if at all you wanted to debug something, you can put a breakpoint either of these two methods. Okay, if I go back to this particular method, inside this it will validate the authorizations for the particular user. It will look for the standard authorizations only. So look at this material authorizations, it will check, and it will check for the you can see plant related authorizations, it will check in the backend, and it will also check for your valuation related authorizations over here. So these are not MDG specific authorizations. It will look into your standard material master authorizations only. Okay, so you can actually look at this and debug put a breakpoint over here to look at that if something is missing. Okay, so this is one thing related to the authorizations. And similarly, you will also have some method related to save. Save. Yep, save is the one. So this particular save method will get triggered at the time of the activation process or at the final approval process, because inside this save method, it has the logic to read the data from the staging tables, and finally it calls your it creates the material in the underlying ECC. So this save method will get triggered during that time. If at all you are reading something, you are searching something, this read value will get triggered. Query will be when you are searching in bulk. Okay, so this particular query will get triggered. Okay, so likewise there are different methods are there which triggers at different instances. Okay, now if at all you wanted to develop any custom object as a using a reuse mode, that you need to develop this particular access class. That means you need to create an ABAP class, ZABAP class, and when you extend your ABAP class with this particular interface, you see this USMD underscore PP underscore access. So when you extend your custom ABAP class to this particular interface, then automatically those methods will come into picture. And out of all these methods, the mandatory methods that you need to implement is save method, read method, query method, and you also will have something this validate and derive methods. So those are the 5 bare minimum methods that you need to develop, and rest all are optional. Okay, so we will look at this access class again in detail during our technical discussions. I'm just giving a glimpse of that what is this active area and how it is linked to the reuse mode. Okay, so now this is the story for the reuse mode. Now, when it comes to flex mode, there is no access class available for the flex data model. Okay, so there is no access class, and because here in case of flex mode, there is no need to put the data into your underlying ECC tables. Okay, or if at all, because once the request got approved, the data will be available in your staging tables only, your active area tables only. So that means even when you do the read operation also, it will read the data from your staging tables only. The active records will be read from the staging tables only. Okay, so that's why SAP haven't included or developed any access classes for the flex mode. Okay, so that will be taken care by your MDG framework only. For the flex mode, it will be taken care by the MDG framework. We no need to develop any access class or anything.
Akshay, if you don't mind, can we go back to the data model folder, SAP IMG?
Yes, I'm just going.
I just wanted to look at that. Yeah, so can you scroll to the right? How is this, what are all the links?
No, nothing, only access class is the important one here.
Okay, so there's, okay, only access, okay. I thought there was more links. Okay, thank you.
Only this access class. Okay, so now there are two ways. Like let's say, for example, my requirement is I wanted to develop a custom data model using reuse approach only. Okay, so that means in this case you have to define an access class for that one. That requires some lot of custom coding. I mean, that means you need to define your access class, write the logic, implement those methods and everything. Okay, so this is the suggested or recommended approach. Okay, that's how even the SAP partners, they developed article master and they also developed EAM objects using the U1 data model. Okay, so that means they created their own access classes for this one. Okay, so developing this access class will take some time. Okay, you need to look at all the functionality, how it works on ECC side, and accordingly you need to put that logic in your access class for save, or it can be for validations, all those validations and everything. You need to write the logic for these for these particular objects. Okay, so that's all. What they have done is the SAP partners, they look at to create an article master, the transaction code is MM41. Okay, so they looked at the standard transaction, how it behaves, what are the validations it takes, everything, and the entire all those things they coded in the access class. Okay, now for us, for the custom data model, assume that Y1 is the data model which I'm going to create. Though it's a product master, material master only, I cannot use the standard material master access class because my entity names are different in my data model, custom data model, whereas MM has some different entity names. Okay, so inside this access class, they hard coded, because this MM access class that I just showed, that always looks for the MM data model, and the entities of MM data model are hard coded inside this access class. So we cannot create a generic access class for any which can be used across multiple data models. It will be all the time 1:1 relation, or probably 1:n relation. I would say you can have multiple n number of access classes also for one data model. I will come back to this situation a little later, but for now, assume that the data models, when I say reuse, that means it will have something called access class associated with the data model. Okay, so what we will do, first we'll go to SC24 and create one ABAP class, access class, and extend that interface I just showed you, if underscore pp underscore usmd underscore pp underscore access. So this is the interface that we need to extend. So once you extend this particular interface, then you assume that you implemented all those methods, the bare minimum methods. So your access class is ready. Now what you will do is you'll go to that go to this particular data model. Okay, so you go to this reuse active area, go to edit. Okay, now click on new entry. Okay, click on new entry and give any text, free text, Z prod master, something like that. So this is what the name, that logical name I'm giving to my Z access class, whatever the Z access class I just defined. Okay, something like this. Okay, I'll provide some description. Now, once you save this, take this particular access class. Okay, so then take this active area and assign to your data model in the previous configuration. I'm not saving anything here. I'm just showing you here. In tomorrow, when we get into our own system, that way we will create all these things. Okay, so once you go back to the data model, here you do an F4. Whatever the active area that you defined, it will show you over here your custom active area also. Then you can just select and assign that one. Okay, that is for the custom data models. For the standard data model, never ever change this one. It always expects this particular active area only. Okay, so likewise, we can create our own access class for the data models. Okay, any questions on this? Okay, so now after that, this particular prefix is there. So basically this prefix is in the backend, as I said earlier, once you do all the entity types, attributes, and click on activate button, system will generate some the staging tables in the backend automatically, right? So for that particular staging tables, what is the prefix it has to use? So that's where it will use these prefix names. We will see when we create our own data model tomorrow, that time we will assign some prefix and you will see how the staging so this prefix will be get added to the staging tables that get generated. And package is nothing but the objects that you are creating, it will store under a particular package. Now after that, who created this data model, when was the last modified, then you will have something called the last modified date and time. Now there is something called active version. So this particular active version is, let's say for example, initially, you can see how many, there are 3 statuses are there, none, same, and different. Okay, so what does this mean is, let's say for example, I'm creating a brand new data model. Okay, so I'm just creating Y1 as a brand new data model. Initially, the status will be set as none originally. Okay, so we can just check this here as well. Let me edit. Okay, so click on new Y1 data model Roadmaster. I'm giving assume that we are creating this as a reuse flex mode. So I'm just selecting MDG, or I can leave it blank also. I'll enter some prefix. Okay, now here you can see the status shows it as none originally. So that means none means it always indicates it's a, so none means it always indicates that it's a new data model. Like in ABAP also, if you are creating any program or class or any ABAP object, originally the status will show it as a new. Until you click that first time activation button, till then the status shows it as new. It is just we are creating it now, we haven't actually activated it. Till now, not even once we haven't activated. Now I created under this data model, I added the entity types, I added the attributes, and finally I click the activate button. So when I click the activate button, this none will turn to same. That means what it indicates is same means you will have there is no inactive version. So that means what happens is the active version and inactive version are same. There is no inactive version kind of thing. Okay, even when you activate any particular object, SE level or in ABAP object, the status will turn from new to active. Active, that object is active. Here same means your inactive version is same as active version. There is no inactive version. After that, once I click the activate button, next I decided that I forgot to add one more entity. Then I added another entity over here. And I click the save button. I haven't activated it. When I click the save button, what happens? This same will turn to different option as X different. The third option. Different means what it indicates is there is an active version exists. On top of that one, you are doing some changes and you haven't activated it. That means different means your active version contains only one entity, if you look at, if you go back to your staging table and look at the staging tables, you will have only one staging table. This is still under process. I mean, it's not yet activated, finalize the changes. Okay. Now, once you complete your changes, you added a new custom entity and added all your attributes and click the active button this time. This time, that means your inactive version will turn to active and the status will again set back to same. So from now onwards, whenever you do the, it's always between same to different. If you're doing some changes and hit the save button, status will turn to different because there is an inactive version which is not yet activated. And after that, once you click the activate button, it will turn back to same. So it will be switched between your same and different. Okay. So that's why you can see here in this particular data model, someone actually modified. First time when I'm creating, the status will be none. And once I activate that, then the status will be same. Now, if you look at this particular data model, the status shows it as different. That means it's already activated. And after that, on the active version, someone did some changes and they haven't yet activated. That's why the status shows it as different. So that is a difference. Like originally, first time you'll have none. After that, it will turn to same. Then after that, if you do any changes, then it will be always switch between same and different, the statuses. Okay, so that's it at the data model level. Okay, so once you do all these things, right? So then the next one is select your data model, the custom data model, and go to entities, entity types. Assume that I wanted to create a new entity here. Okay, so for that one, you need to go back to edit mode and click on a new entry. So that's where I'm creating one new entity here. So the entity name will be, let's say, for example, Z, some name I'm giving over here. Okay. So always your entity name should start with Z. Any custom entity, always it should start with Z or Y. Okay. So I'm just giving this, and just this is the resort namespace for the customers. Okay. So you need to give something like ZProd or something. Okay. Now, when you are creating entity, so this is the very, very important setting at the entity level. You can see any entity that you are creating, you need to categorize it onto this 1, 2, 3, 4. 1, 2, 3, 4. So you need to do that categorization. The entity has to be defined either as a type 1 or type 2, type 3 or type 4. Okay. So this we call it as a storage use type. This is very, very important setting at data model level when you are creating entities. So that means either you are extending when you are creating a custom entity under the material master, or else you are creating a brand new data model and entities. In both the cases, whenever you are defining a new entity, you need to categorize into 1, 2, 3, 4, either of these 4 ones. Okay, so this drives the complete, whether as I said earlier, I said for every entity, system will generate a staging table in the back end. Okay, so that is true only when you are creating the entity types. If you select the category as 1 or 4 or even 2, for 1, 2 and 4, system will generate a staging table in the back end. When you're selecting these 3, system won't generate a staging table. So in what cases we will use which entity type, that we will discuss now. Okay, so this important setting at entity level, that we call it as a storage use type. Storage use type. It can be 1, 2, 3, 4. Okay. Sometimes we call it as a SU type. In short, we call it as a SU type also. SUT or SU type. Okay. So when you are creating a new entity, you have to mandatorily choose either of these 4 options. First, let's discuss about 1 and 4. 1 and 4 are always the straightforward. Let's say, for example, in your entire master data, there will be one parent node or parent table will be there. Example, if you are taking example of material master, what is the parent table, the base table for material master? Mara is the base table. Mara is the base table. Okay. If you're taking business partners, so you have the table called BUT 000. which stores the basic information of your business partner. Okay, so likewise for every master data, there is one base table will be there, the parent table will be there. Okay, so that means in MDG side also, you will have one material, one parent entity. That entity we call it as we define it as a type 1. That means, so if you look at this, you have let's say for example material. In data model, material is the parent entity. SAP defined this as a SU type 1. Okay, so after this, then you have something called a plant entity. These are the childs. You can have something called a sales entity. Sales entity. You can have valuation entity. Valuation entity. And you can have something called a storage location entity. Storage location. Okay, so likewise you will have all the other entities. Okay, now so this one, these child entities which has a dependency with the parent entity, these child entities we define it as a SU type 4. All these are different SU type 4s. SU type 4s. Okay, so like this. So now what happens, if at all you wanted to create a material, always it has to start from your type 1 only. That means first user has to fill the type 1 data. For him, he doesn't know type 1 data. I mean, on the UI application, we will show some that material number, material type, material group. Then all those attributes are part of your type 1 type 1 entity, like your material type, your material group, your unit of measure. So all these are your attributes are put it under material entity, under this particular entity, because these attributes are common across. These are the plant view, sales view, valuation, and all those things. But this is the common basic attributes will be there at your parent entity. So in MDG world, if at all you wanted to create any master data, you should have a type 1 entity. That is a parent entity. Then first you will fill the important mandatory information at your type 1 entity. And based on this, once that is done, based on this one, you can extend that the same material to multiple plants. And you can extend the same material to multiple sales orgs, multiple valuations, multiple storage locations. So these become your child entities or child information. Okay, without parent entity, you cannot edit or you cannot create sales or valuation or anything. Okay, always it has to go through from your parent entity only. Okay, so in that case, we need to first define which one will come under type 1 entity. Only you can have n number of type 1 entities under a data model, but every type 1 entity will have its own childs. If you are taking the finance data model, in finance data model, it's a one data model only, OG. Under that one, you will have cost center, profit center, then GL account. All these are different type 1 entities. Under each type 1 entity, you will have some childs. So this is one unique master. This is again another unique master. This is again another unique master. So under one data model can represent multiple masters. But under each master, there should be one bare minimum type 1 entity. If you are creating a data model without type 1 entity, if you just create a type 4 entity and try to activate, system will throw an errors. So always first you should create a type 1 entity and define certain properties at the type 1 entity which falls under the type 1 entity, and after that you can keep on adding your child entities. So all your child entities we'll call it as a type 4, we'll define it as a type 4 entities, and the parent entity will call it as a type 1 entity. Even in material master also, if at all you are doing some extensions to the material master, okay, either you add some attributes under at the plant level or at sales level or at the valuation level or even at the type 1 entity level also, you can enhance those entities with your custom attributes, or else you will create your own Z entity over here, Z product location attributes, something like Z product location attributes. So you can Enhance, always you can enhance with a type 4 entity only in data model or any standard data models. You cannot create another type 1 entity under data model, because the data model designed in such a way that always this is a type 1 entity and there are some standard type 4 entities are there. Either you add some more type 4 entities as a childs to your material, or else extend the standard existing entities with some custom attributes. Okay, now in this case, if you are creating custom data model and you define one type 1 entity and you define some childs to that one, and then when you activate the data model, so system will generate the staging tables corresponding to your type 1 and your type 4s also. So staging tables will be mandatorily generated for your type 1s and type 4s. Okay, if you look at this one, when the descriptions, read the description for your 1 and 4. So what happens? Changeable via change request generated. I'll explain what is this change request concept. Okay, so let me first explain the change request concept. We will discuss in detail about the change request concept in process model. But at least we will keep on hearing this change request in MDG. That is a very important one, but that we will discuss in detail in the process modeling. Since we read the description where change request is mentioned, I'll just give you a small I'll try to explain what is this change request concept. What happens is in your organization, let's say for example, in your organization, you wanted to travel from one place to other place. So for some business purpose. So what we will do, we'll log into the company portal and we'll raise a travel request. So I'm as a user or employee. Okay, I'm as an employee, I will log into the portal. Okay, I'll provide all the information, travel dates and everything, and I'll submit the request. So then what happens? It will go to my manager. Okay, so manager will review the data entered by me, and he will actually either he will ask for some more details, or else if he is fine, he will just approve from his side. Then it will go to finance department. Finance department will look at that the cost center is a valid cost center or not. So they will validate all the finance aspects and they'll approve this request. Then finally it goes to the travel department, the travel desk. Okay, so it will go to the travel desk, and the travel desk will call you, the employee, and they will make all those, give some options for you. And finally they book the tickets. Okay, so this entire life cycle, right? What happens as soon as you submit your request here, system generates one ticket number. Okay, the number is, let's say for example, 123 is a ticket number, and this manager also will open the ticket number and will take an action. So the entire life cycle of your the travel request can be tracked through this ticket number. It starts from here and it ends at this travel department, whether it is through proper ticket booking, or maybe they will be rejecting this one, maybe if the travel is not required. But in the entire, all these different users, right? So they will actually track using your ticket number. In the same way, in MDG also, what happens is, if at all I wanted to create a material, then system will generate something called change request number. Change request. Okay, so system will generate something called we call it as a CR, that means change request number. Okay, a unique number for your change. Okay, it generates one change request number, let's say for example 100. Once the end user, the requester, submits his request with all the material details, it goes to the approver, and the approver will open the same change request number, and he will correct and he'll take an action. Then it will go to the steward, and from steward, once he finally approves that one, it will initiate something called in the backend activation process, and your request will get, your material will get created in the ECC or the underlying database table. Okay, so any change, this is a creation scenario. After that, I wanted to edit that particular material. Then what happens? I'll go to the search screen. I will search my material with the material number, and again I will edit that particular material. Whenever I'm trying to edit that material, system will generate again one more change request number. So, and it follows the same path. So that means any change that you do in MDG, that will system automatically generate something called change request number. whether it's a create scenario, it's an update scenario, or it's extension scenario, or it's a block scenario, or it's a delete scenario, any scenario. Okay, so uniquely for that particular change, the change request number will be associated. And you can refer back this, you can, if I look at my material, and I can see all the change request numbers so far, right from the creation till today, how many change request numbers are generated. So every change request number will have one, it will have some changes. Okay, so you can trace back that, okay, using in which change request number this particular change has done. Okay, so that will be for auditing purpose. That's why we will have this, all this information gets captured in MDG. Okay, so any change, whether you are creating or changing, if system by default will assign a change request number. Okay, and the change request number information will be only within MDG. Once your material gets created to underlying ECC, your actual material number will flow back to the underlying ECC. Your change request numbers and all those things are MDG concepts. It nothing to do with your underlying ECC or S4. Okay, so now if you look at this particular, with this concept, if you look at this, we'll discuss more, because the entire process modeling topic revolves around the change request concept only. Okay, so now if you look at this one, changeable via change request, that means any type 1 entity can be always, it has to be changed via change request number. Without change request number, you cannot edit the data in MDG world. I can go to MM01 or MM02 and I can edit that record without any change request number, because there is no change request concept on ECC side. But using MDG UI applications, if at all I have to create or edit a material, master data, system automatically generates the change request number. That's why you can see here, changeable via change request. So this
can you please repeat this again, Akshay? This is changeable via change request, this part.
Okay, so in MDG, what I'm trying to say is, any master data you wanted to change or you wanted to create or edit, system will associate a unique number, change request number. Okay, so here, if I'm selecting it as a type 1 entity, that means always type 1 entity data. Type 1 entity data means the attributes under this particular entity. We will be creating some attributes under this entity, right? So the attributes under this type 1 entity can be changeable via change request number. Without change request number, you cannot edit the data. System automatically assigns the change request number to you. We will see in the in the demo in tomorrow's session. Okay, so every change will be associated. It has to go through the change request concept only, and generated database table. So for type 1 entities, system will generate a database table. For material entity, there is a staging table got generated in the backend. So likewise, for type 1, system will generate database tables, means that is nothing but your staging table will get generated. If I choose this option, so the attributes under this particular entity has to be changed via change request number, and system also generates a staging tables for this particular attributes for this particular entity. So this is the main entity. This is the main entity in my master data. This is a parent entity. Now after this, all the dependent entities. Now you can look at this fourth option. The concept remains same, but if you look at the description here, also it generates the database tables for your childs also. Similar to your parent, it also generates the tables for your child entity. I mean your childs also. Now what is the difference between, you see here, via other entity type? What does here also system, it requires you need to have a change request number only. Okay, but there is a slight difference with this text, changeable via other entity type. That means what happens is here. Okay, so I'll go back to this particular one. Now you can see here. Okay, so I have my type 1 and also I have my type 4s also, childs also over here. Okay, so the description here, always when if at all you wanted to edit the attributes at the plant level or at the sales level, though it has to be via other entity. Other entity means via parent entity. Okay, I cannot directly go and edit the plant data. Okay, first I need to log that particular material. Okay, so it has to come from the material only, from the top level only. Okay, I need to log that entity, and then I can edit these records independently. I cannot do the changes, but you can do the changes for your type 1 entity independently. But when it comes to that type 4 entity, your changes are always in the context of your parent entity. Okay, so that's why you can see the description as via other entity type. So why they didn't mention? Okay, so that means, let's say for example, take a simple example of here you have material. Under this you have a plant. Under plant you have something called storage type. Under this you have something called storage location. So this is possible here. This is your type 1, SU type 1. This is your SU type 4. This is again another SU type 4. This is again another SU type 4. Okay, so this is also type 4, this is also type 4, this is also type 4. For this particular type 4, the parent is this one. For this particular type 4, the parent is this one. And for this one, this is the one. Okay, so that's why they said for the type 4, the description said other entity type. The other entity type can be another type 4 or it can be type 1. So I can change the storage location information for a particular storage type. That means in the context of the storage type. And I can change the storage type information at a plant level for a particular plant. That means at the plant level. And the plant related information I can change for a specific material. So there is an attribute called ABC indicator at the plant level. So if I'm trying to edit that the ABC indicator from X to Y, the value, that means that is applicable only for this particular material, for this particular plant, the change that you are doing will be applicable. So that means always the type 4 data that you are editing, that will be in the context of your parent node. So the log starts from here. First system, when you're trying to create a change request, system first log this material object, depends on the change. If you're changing at this level, it will log this entire hierarchy technical in the backend. Okay, so that's why type 1 and type 4, there is no difference. In both the cases, staging tables will get generated. System will it automatically generates a change request when you are trying to edit. All that will happen, but the description is right. For parent level, you can if you are trying to edit, there is no dependency. For parent, there is no super parent. It will be just that it starts from that one itself. But when it comes to type 4s, if you are trying to edit the plan data or sales data or anything, for those type 4s, the change request, the data can be changed via or in the context of the parent entity. Okay, so that's why you can see the description SAP has provided something like this. Okay, so one is type 1, other one is type 4. In both the cases, system will generate the staging tables, and system change request is mandatory whether you wanted to edit the type 4 data or you wanted to edit the type 1 data. Is this clear till now?
Yeah, it's clear.
Okay, great. So for type 2 and type 3, I'll just stop for today here. We will cover up type 2 and type 3 in the next session. Okay, and after that we will create by that time we will get the system access. So we will create our custom data model. Okay, so we'll create a custom data model, and we will also discuss about, once this is done, we will discuss about all other parameters that we have the settings over here.
Yeah, I just have one question, Akshay.
Yeah.
This is going back a little bit to the what is that? The reuse and the flex.
Sure.
Yeah. So in reuse and flex mode, because we're replicating all the information to the target system, right?
Yeah.
In both scenarios, reuse and flex. It's
Yeah.
just that in reuse, I think it's in one of the scenarios, the inactive and the active is both in the staging table.
Yes.
Is that correct? Okay, so
no, in use you have a separate set of tables. This is for inactive records, and this is for active records.
Right.
In case of reuse, yes.
This is for reuse, and for flex, inactive and active will both get stored in the staging table. and then it will be self-replicated to the the ECC table, correct?
Yes, that's true. That's true.
Okay. Can you give me two scenarios on why, or some scenarios on why a company would choose the hub over, or sorry, the flex over the reuse, or the reuse over the flex?
Yeah. So the main important point here is for the flex, especially SAP build this flex concept, keeping in mind that this one, your finance objects, only for finance objects, just keeping in mind with the finance objects, SAP actually come up with this kind of flex concept. Why this is required means, because the nature of the finance objects is like whenever you are creating any finance object, you need to associate a time also, validity period. Whereas when I'm creating a material or partner or anything, I don't have any that validity concept. But for the finance objects, you have something called validity concept. Okay. When I'm creating a cost center, profit center, I need to mention the validity period. Okay. So this cost center is valid for this 6 months. After 6 months, I cannot use this cost center. That will become an invalid one. Okay. So that means what happens is, with the validity period, when you are setting up this validity period, all the finance objects are also interlinked. That means what I'll say is, cost center you have, profit center, then GL account. Okay, I'm going to set up a, I'm creating a new plant in a particular location. Okay, for that, when I set up a new plant, I need all these three objects. Okay, the validity period of all these three objects is, let's say for example, 1st Jan to let's say for example 30th June. This is the validity period for all these things. Okay, so instead of when you are creating these objects individually, you need to assign the different this validity period separately. Then instead of that one, what SAP come up with is, there is a concept called addition concept. Okay, so there is a concept called addition. We will discuss when we are talking about the finance thing. Okay, so let's assume that addition is nothing but it's a one concept. Okay, when you create an addition, you will also assign some validity period for this addition. Okay, that means it's the same thing, 1st Jan to 30th June. So this is the validity period I have given for this addition. Now what happens is, when I create a cost center, I will assign this addition. So when I assign this addition to my cost center, automatically this validity period will be adopted for my cost center also. Similarly, when I'm creating a profit center, this also I will assign the same addition. So the same validity period will be adopted for all these three objects. Okay, so then there is no change in the validity. So the validity you are assigning it somewhere at a different level, top level, parent level, and you are using this using the addition for all these objects. This is one concept. And after that, in my MDG, what happens is, I create a cost center separately. It's a separate change request. I create a profit center separately. It's a separate change request, and GL account also. But what is important to my target system, I need all these objects to be replicated at the same time. Okay, it's not like as and when I create, it should go that each individual object. Okay, because these are the interdependent objects. So then what happens is, I create a cost center, and that because I'm assigning this addition, right? So this addition also controls the validity, and it also controls the replication also. At what point of time you need to replicate. Okay, so then what happens? I create a cost center, I create a profit center, I create a GL account, and what I will do is the same validity period will be assigned to these objects. And after that, I will release my addition. Once I release my addition, that is the time these three objects will be replicated to the target system in one shot. So this addition controls the validity periods and the replication. At what point of time you wanted to replicate. So till then, I created a cost center, and tomorrow I'll create a profit center. So if I use the reuse concept, what happens, as soon as this request gets approved, it automatically push to the underlying ECC. But I don't want it to replicate to any of my active areas, whether it is the self-replication or to the target system, until my addition gets released.
I see.
That's why I wanted to keep this data in my staging table only. Though it's an active record, I wanted to keep in my staging area only. Only when I decide, okay, on 31st December or 1st January, I decide that, okay, let's release this edition. That is the time all the objects under this particular edition will be replicated to the target systems. And even if I configure a self-replication, those objects also will be moved to my underlying ECC. Okay, that means you need to store. Sometimes there is a requirement where you need to store, though it's an active record, you need to store that records for some time in your staging table. Those are the active records you wanted to store. So that's why SAP come up with this flex concept where you can store your active records into the staging tables itself.
Okay, that makes sense. Thank you.
Okay.
So actually, question. So on the governance process, are you planning to do a demo of a simple, like a two-step process, right? Like for materials, for example, if you take, I have a requester, and then I initiate a request for change or anything, and then you have an approver, and then and it's out of the box, and a standard, nothing custom before you go into the custom, defining that process and how that works in terms of configuration and in terms of at that point, I think it would make sense to add on custom fields or totally new steps in the process.
Yes.
Are you planning to do that?
Yeah, we are doing so. So we will go through the standard two-step workflow process. Okay. It's a plain scenario, like a requester will create the data, it goes to approver 1, and after that it goes to approver 2. So it goes to approver 2, and it's a two-step process. Okay, now on top of that one, I wanted to send some emails, or I wanted to trigger two-step approval process based on certain conditions. Okay, so all those things won't be handled in the standard out-of-box workflow. Okay, so that's where we need to configure the workflows as per our needs. So let's say, for example, I have a requirement, requester will create, and it goes to the approver, and approver one, what he can take call that whether he wanted to directly activate the record, or he wanted to send it back to approver 2 for one more review. Okay, so that means it's not all the time two-step approval. It depends on that requirement. Either he can submit to the approver 2, or he can actually directly approve that one also from his side. Okay, so likewise, other than this two-step standard flow, any additional changes you want, or I want a parallel workflow. Okay, so any additional requirements, business requirements we wanted to handle, that's where we will discuss about the configuring our workflows as per our business requirements. Okay, so I will be covering both the scenarios. The standard workflow is a simple workflow. It will just hardly take some 10-15 minutes. After that, what is important for us is how we can actually make it as a two-step approval process, one-step approval process, or three-step approval process, or how I can make it as a parallel workflow, and how I can trigger emails, how I can decide certain things at the workflow level. So all those, we will be discussing those things as well.
Great, thank you.
Any questions? Great. So by tomorrow, before our session, I'll ensure that we will have the system. Okay. So, and then we will start creating the data model, and we will discuss the other remaining concepts in the data model tomorrow.
Okay, Akshay, thank you.
Okay.